Hello everyone, welcome back to online lecture series on fluid mechanics and hydraulic machines. We are continuing our topic of dimensional and model analysis. In our previous lecture we have studied up to the Rayleigh's theorem, Rayleigh's method, and now we will study the Buckingham's pi theorem. So let's begin. So here, as I was telling you in previous lecture, that Buckingham's pi theorem is useful when more than 4 number of variables are present in any physical phenomena for dimensional analysis. So first of all we will write down the statement of Buckingham's pi theorem. If there are n variables that is considering dependent and independent together, dependent and independent, together in a physical phenomena, and if it contains m fundamental dimensions, that means generally the number is 3 only, m, l and t. Then the variables are arranged variables are arranged into n minus m dimensionless terms. Each term is called pi term. Now, this is the statement of Buckingham's pi theorem. So, here there will be total number of variables to be n. It contains all dependent and independent variables together in a physical phenomena. And if it contains m fundamental dimensions that are generally m, l and t, then the variables are arranged into n minus m dimensionless terms, and each term is known as pi term. So now let us say that take a theoretical example first. That is, let us say x1, x2, comma x3 to xn are the variables. Then out of this, x1 is dependent variable, and here these are independent variable. So we can say that x1 is a function of x2, comma x3, comma up to xn. Or we can also write down that f1, that is another function combining all dependent and independent variables x1, comma x2, comma x3 up to xn is equal to 0. So here let us say that m are the fundamental dimensions. M is equal to number of fundamental dimensions. So we can have n minus n pi terms. N minus n is equal to dimensionless pi terms. So we can write down here that f is pi 1, pi 2 up to pi n minus m is equal to 0. Now, how to obtain this pi terms? That is the main thing. So they are obtained in this way, that each pi term contains m plus 1 variable m plus 1 variables and m is number of fundamental dimensions known as repeating variables. So here you can write down pi 1 is equal to x2 raised to a1 x3 raised to b1 x4 raised to c1. These three are repeating variables, and here we can put non-repeating variable, that is x1. Then pi 2 is equal to x2 raised to a2 into x3 raised to b2 into x4 raised to c2 into x5. And up to we can go till pi n minus m, which is equal to x2 raised to a subscript n minus m, x3 raised to b n minus m, x4 raised to c n minus m, xn. So this is the way we get this pi 1, pi 2 up to pi n minus 1 terms. So let's copy this work into our main slides. So now there are few things we need to take care is selection of repeating variables. So here we need to select one geometric variable which is, it can be length can be height or it can be a diameter also. Then second is flow property. So it can be like velocity or it can be acceleration also. Then third one is fluid property. So it can be dynamic viscosity, it can be a density, like that. So let's copy this. Now we will directly take the example for this. So here we will be taking a physical phenomena here of resisting force in a supersonic plane. So R, let us say R is the resisting force which depends upon here L, that is length, V is the velocity, then mu is the dynamic viscosity, rho is the density, and K is the bulk modulus. So it can be said that R is a function of L, V, mu, rho, and K. So total number of variables, if you see, 1, 2, 3, 4, 5, 6. So n is equal to 6, and fundamental dimensions are going to be m, l, and t. So m is going to be 3. So number of pi terms will be n minus m is equal to 3. So we will have 3 pi terms. So we will have final answer as f1 of pi 1, comma pi 2, comma pi 3 is equal to 0. So now we need to select the repeating variables. So R cannot be taken as repeating variable because it is a dependent quantity or variable. So one, we need to select a geometric property. So let me list it over here, repeating variables. One is taken as geometric, so it is L. Then we need to take one as a flow property, so we have taken volume, velocity, and third is fluid property, that will be taken as density. So now let's write down the pi terms. So pi 1 is equal to L raised to A1, V raised to B1, rho raised to C1 into the first will be the dependent one, that is R, which will be non-repeating. Pi 2 is equal to L raised to A2, V raised to B2, rho raised to C2 into we have mu pi 3 is equal to L raised to A3 V raised to B3 rho raised to C3 into K. So here first we will begin with pi 1. So let's begin. Pi 1 is equal to L raised to A1 V raised to B1 rho raised to C1 into R. M0 L0 T0 here L A1 L B1 T minus B1 M C1 L minus 3 C1 M1 L minus L1 T minus 2. So here we have M C1 plus 1 L A1 plus B1 minus 3 C1 plus 1 T minus B1 minus 2. Here we have M0 L0 T0. So we have obtained the value of C1 is equal to minus 1, B1 is equal to minus 2, and here we have A1 minus 2 plus 3 plus 1 is equal to 0. So A1 will be equal to minus 2. So we are getting pi 1 is equal to R upon rho L square V square. That is the value of pi 1 term. Then let's move forward with our next pi term, that is pi 2 is equal to L into V2 rho C2 into mu. So this all terms will remain as it is. So here L A2 L B2 T minus B2 M C2 L minus 3 C2 M1 M1 L minus 1 T minus 1. So here finally what we will have M C2 plus 1 L A2 plus B2 minus 3C2 minus 1 t minus v2 minus 1. Okay, let me correct this. Minus v2 minus 1. So we will be getting here we have m0, l0, t0. So we have obtained the value of c2 is equal to minus 1, v2 is equal to minus 1, and regarding a2 we can get minus 1 plus 3 minus 1 is equal to 0. So a2 is also minus 1. So we have obtained the value of phi 2, that is equal to mu upon rho v L. Now let's move forward to third pi term. Let us write down over here that phi 3 is equal to L raised to A3 V raised to B3 and rho raised to C3 into K. So here again L A3 L V3 T minus V3 L C3 L minus 3 C3. Instead of K, that is bulk modulus, it is M1 L minus 1 T minus 2. So finally we will be having M C3 plus 1 L A3 plus V3 minus 3 C3 minus 1 T minus V3 minus 2, and here we have M0 L0 T0. So C3 is equal to minus 1, V3 is equal to minus 2, and for A3 it will be minus 2 plus 3 minus 1 is equal to 0. So A3 will be equal to 0 in this case. So finally we can write down pi 3 is equal to K upon V square rho. So now we are in position to combine three pi terms, that is function of R upon function of phi 1 comma phi 2 comma phi 3 equal to 0, and function of R upon rho L square V square comma mu upon rho V L comma K upon rho V square is equal to 0. So we can write down that R upon rho L square V square is equal to function of mu upon rho V L comma K upon rho V square. So we can write down R is equal to rho L square V square function of mu upon rho V L comma K upon rho V square. That is the final answer. So this is the way we can solve using Buckingham's 5 law. So let's copy this work into our main slides. So that is the end of today's lecture. Thank you for watching this video.